Okay, in this video we're going to look at tan or tangent. Okay, so let's draw our nifty triangle again. Wait, let me do, oh well, it doesn't matter. Let's just do this. So let's just name our triangle. This is always step one when we do trigonometry. You have to name your triangle. If you're not going to be able to name the triangle, you're going to get confused about it. Practice it. But you have to get it right, otherwise you won't be able to do any of the work really. So if this is my reference angle, the one here would be my opposite. The one actually touching would be the adjacent. But how do I know this is not the adjacent? Because it's actually also touching. Well, it's because this is the 90-degree angle, and the one that's across the 90-degree angle is the longest side in my triangle, and the longest one is always the hypotenuse. Okay, so now we have named our triangle. Now the tangent function, let's write it here. Tan is actually, this is a lot like gradients. So if you haven't done straight lines and gradients before, it would be weird because usually people do that before they come into trigonometry. But if you haven't, it's still weird, but it's fine. There should be a course soon on that. But for now, tangent is knowing what my opposite over my adjacent. So what does that mean? If I was throwing something from here to here, you would understand that the gradient or the slope would be let's do this side. So here, if I had gradient, which is the m value usually, that would be the difference or the change in y over the change in x. And it's very similar here. So if I'm looking from this point to this point, and let's say this was a straight line going there and there, you would agree if I wanted to work out the gradient of this line, I would take the difference in y. So what's the difference in y? Well, it's the opposite side, that distance, over let's say the distance traveled or the change in x, which would be this. So this would be my y value, and this would be my x value. Okay, so for tangent, it's basically just trying to figure out what the slope is of a line. And let's just take a look at, I'm going to draw a better looking triangle because I want to show, let's say, one example here of something that you should kind of know off by heart. So if I had a 45-degree angle, and I drew this, you would agree that the gradient, what would the gradient be of a line that's 45 degrees? It would just be 1. Why? Because this distance of the triangle, well, these two lengths would actually be the same. Because if, let's say I did like let's say, sorry, I lost for words there for a second. If I were to work out the gradient and I counted how many, let's say this was a grid paper, and I'm counting how many times I hop from here to here. Maybe I hop 1, 2, 3 times, and then to go up to get to the same line, I'd also do 1, 2, 3 lines. So I would have 3 over 3, and that would be 1. And the same with tan. The tan would be the opposite. So the opposite and the adjacent, so in this case the opposite and the adjacent, if I were to place them on top of each other, they would be the same value. So it would be 3 over 3 or 4 over 4. In this case, 3 over 3, let's say. Then that would be 1. So it's interesting that the tan of a 45-degree angle line, or the tan 45, will always be 1, because it gives me the idea of the gradient of that line, how much I'm rising versus how much I'm running. Let's just check I'm not lying. Tan 45 equals 1. That's amazing. But now the next question is, what would happen if the angle gets smaller? So let's just think about that. If the angle gets smaller, what side is getting smaller? Or what am I doing less? I'm probably going to do less in the opposite. So let's sorry, this is a lot of squiggling. Let me just take this off. Okay, there we go. If I drew a different triangle here, you would agree this would be less than, let's say this was 30 degrees. you would agree that in this case, this line stayed the same. So the adjacent side, that stayed the same, but the opposite was smaller. So what happens when we have a fraction? Let's say it was 3 over 3. What happens if this becomes smaller? 2 over 3. What do we get? We get a fraction. Okay, so let's say tan of 45 will always be 1. So whenever I go at a smaller angle, let's say the tan of 30, tan 30, I get a fraction. And if I go, let's say that's 0.57, if I were to go even smaller, the tan of 10, I get an even smaller number. Why? Because as this line decreases, or this angle decreases, then this value gets smaller and smaller and smaller. So it might even get to 1 over 3 or even smaller. So that's what happens with any angle that's less than 45, the tan value will be a fraction. But what do you think will happen if we get a bigger, let's do a bigger one, let's draw a bigger angle. What happens if I have this? Sorry, I'm sketching over here. So let's say that was 60. In this case, the opposite side is getting bigger because that length is getting bigger. So if I have let's say I started with 3, 3, but now suddenly the 3 side or the opposite side is getting bigger. So I would have something like 4 over 3. So what would that do? So suddenly if it was equal and it was a 1, then becoming an improper fraction would probably be more than 1. So let's just see what happens with something like tan 60. It's greater than 1. And tan of 70, oh, it's even greater than 1. So anytime I see the tan angle and it's greater than 45 angles, I can expect a bigger number. And if it's less than 45, I can expect a smaller number, like a fraction. Now, what I kind of didn't say in the previous videos, but I can now touch on it, is when we look at tan can go all the way from 0, well, I won't say it can go from 0, we'll go to that, but it can go from really, really small to really, really big. Whereas the sine and cosine functions, the sine and cosine, our values would always be, okay, strictly speaking, it's between 0, well, let's say -1 and 1. It would be in between that, and cosine as well. But for the angles that we're working in the first quadrant, it would just be like from 0 to 1. Okay, but that's why if you see a value and something says, oh, the sine of an angle is 2, that's impossible. That's not happening. Okay, so, but again, this is just kind of basic theory. In the next video, we're going to actually do some examples. But what I want you to know now is that sine will give you an idea of how much I'm rising, or displacement in the y-axis as a ratio versus the total distance. And cosine would give me an idea of the horizontal displacement, or the x, or the running. And tan would just give me an idea of these two together as a gradient or a slope of a line.